Hi. In the last few videos, we have looked at quadratic equations where there is only one variable in the quadratic. Now, I would like to look at how we tackle quadratics with more than one variable. When writing expressions, we write them in the simplest possible way. In one of our very first examples looking at quadratics, we looked at the expression x squared plus 3x plus 2. When we looked at the rules of exponents, Rule 1 taught us that any variable that has an exponent of 1, we don't have to write it down. So in this case, 3x is actually 3x to the power of 1. We also learned that any variable with an exponent of 0 is actually 1. So instead of 2, we can say 2x to the power of 0. This means that this equation up here can actually look like this. Let's take the coefficients out. Now we can factorize the quadratic into two brackets. We know from past examples that we start by square rooting the variable in the first term. Here we have x squared. The square root of x squared is simply x. So x will be the variable in the first term of each bracket. Now we square root the variable of the last term in the expression, x to the power of 0. Remember that to square root, we divide the exponent by 2. The exponent in our third term is 0. 0 divided by 2 is still 0. So we can write x to the power of 0 in the second term of each bracket. Just like our rule for exponents says, anything with an exponent of 0 is actually 1. And that is why the second term in each bracket in our previous examples has always been a constant. With this in mind, let's look at an example of a quadratic that has two variables. Let's look at an actual example. X squared plus 4xy plus 3y squared. Let's put in our x. I want to start by drawing in our two brackets. So we have bracket number 1 and we have bracket number 2. Now, the first term in the expression is x squared. The square root of x squared is x. So we'll have x in our first term, in the first bracket, and the first term of the second bracket. The third term, the variable is y squared, square root y squared, and we have y. So we can put y in the second term of the first bracket, and in the second term of the second bracket. Now let's look at our coefficients. The coefficient of the first term is 1, and the coefficient of the last term is 3. So we can say 1 multiplied by 3, and we get 3. So let's put 3 up here. The coefficient of the middle term is 4. Let's put this down here. This means we need to find factors of 3 that when added together give us 4. 3 is positive, and 4 is positive, which means both factors will be positive. 3 only has two factors, 1 and 3. 1 plus 3 gives us 4. So we know the factors we need to consider are 1 and 3. The first term's coefficient is 1, so we can say 1 over 1 and 3 over 1. The denominator of the fraction becomes the coefficient of the first term. So we're going to have 1x, which is simply x, and 1x over here. The numerator is the coefficient of the second term in each bracket. So we're going to have 1 in the first bracket. So this becomes x plus 1y, which is simply x plus y. On this side, we have positive 3. So we're going to have x plus 3y. And we have now factorized this expression. Let's do another example. Let's put in our big X. Here we have p squared and we have q squared. So we can start by opening up our two brackets. The square root of p squared is p. So we get p over here, the variable in the first term in the first bracket, and the variable in the first term of the second bracket. The variable in the third term is q squared. So we square root and we get q. So we have q as the variable in the second term and the second bracket as well. Now let's look at the coefficients. The coefficient of the first term is 1 and the coefficient of the third term is negative 10. So we say 1 multiplied by negative 10, and we get negative 10. So we can put negative 10 up here. The coefficient of the middle term is negative 3. Let's put it over here. Now we need to find factors of negative 10 that when added together give us negative 3. 10 is negative, so one factor will be negative. 3 is negative, so the larger factor will be negative. Let's look at factors of negative 10. Negative 10 divided by 1 gives us negative 10. 1 minus 10 gives us negative 9. Let's try negative 10 divided by 2, which gives us negative 5. 2 minus 5 gives us negative 3. This is the value that we've been looking for. So we know the factors we need to consider are 2 and negative 5. The coefficient of the first term in the expression is 1. So we can say 2 over 1 and negative 5 over 1. Now we can fill in the brackets. Let's look at the first fraction, 2 over 1. 1 is the coefficient of the first term, so we get 1p, which is simply p. And 2 is the coefficient of the second term. So we're going to say plus 2q. Now let's look at our second fraction. We have negative 5 over 1. 1 is the coefficient of p, so we are left with p. And negative 5 is the coefficient of q. So we say negative 5q. And we have now factorized this expression. Let's do one more. 4a squared minus 14ab plus 12b squared. 4, 14, and 12 are all even numbers, so we can take out a common factor of 2. Let's do this now. 2 outside the bracket. 4 divided by 2 leaves us with 2a squared. Negative 14 divided by 2 leaves us with negative 7ab. And 12 divided by 2 leaves us with positive 6b squared. There are no other common factors, which means now we can factorize. So let's draw in our big X. Let's start by drawing in our two brackets. We have 2 outside of the bracket, bracket 1, bracket 2. The first term over here has a squared. The square root is a, so we can put a over here and a over here. The third term is b squared. The square root is b, so the variable of the second term in each bracket will be b. Put b over here and b over here. Now let's find the coefficients. The coefficient of the first term is 2 and the last term is 6. So we can say 2 multiplied by 6, which gives us 12. We can put 12 over here. The coefficient of the middle term is negative 7. We can write that in over here. Now we need to find factors of 12 that when added together give us negative 7. 12 is positive, which means both factors will be negative or positive, but 7 is negative, which means both factors are negative. So let's look at the factors of 12. Negative 1 and negative 12 gives us negative 13. Can't be that. 12 divided by negative 2 gives us negative 6. Negative 2 minus 6 is negative 8. It's not going to work either. 12 divided by negative 3 gives us negative 4. Negative 3 minus 4 gives us negative 7. It's the value we've been looking for. So over here, we can say negative 3 and negative 4. The coefficient of the first term in the bracket is 2. So we have to divide both of these factors by 2. Now we can simplify. Negative 3 over 2 cannot be simplified further, and we leave it as it is. Negative 4 over 2 is actually negative 2. So we can say negative 2 over 1. And now we can fill in our brackets. Let's look at the fraction over here. Negative 3 over 2. The denominator of the fraction is the coefficient of the first term. So we're going to say 2a. We have negative 3 as the numerator, so we get negative 3b. Now let's look at our second fraction. The denominator is 1, so our second bracket will be 1a, which is simply a. Then we have a numerator of negative 2, and we get negative 2b. And we've now factorized this expression. You will see more examples like this in upcoming videos.